Good morning to my lecturer and my fellow friends. Today I will be presenting my part, which is lab. So in this picture we have a dead load like what that have given in the question, but unfortunately we must assume FCU, FYH, and D. For this slide, we must find minimum effective depth and get the answer. And secondly, we must find ultimate load and we get the answer. And lastly, we must find the bending moment. Next, after finding bending moment, we must find span effective depth ratio, which is have given the answer. From the answer, we must refer from the table 3.10 PS 8110. From there, we know how much span effective depth modification factor, and we must find allowable span divide D and actual span divide D, and get the answer to find D is educated. From that, we must find bending reinforcement for main steel, which is we have given the answer from in this slide. Next, we must find lever arm. After that, we get the answer, and then we transfer the answer to the AS, and we get our bar, which is 1010 bar at 50 center. Next, distribution. We must find the answer for distribution in order to get the bar, which is T10 bar at 200 center. After get distribution, next we must find the shear. The shear, we get this answer, and then we must refer to table 3.8 BS at 110 in order to get the answer. Next, we must find deflection check. The reason why is we must find deflection check is in order to get is it okay or not. Next, we must find the cracking check. Cracking check is very important in order to get the actual clear spacing. Is it okay or not? Lastly, this is my sketches for slab. That's it. Thank you.
Assalamualaikum, I'm Nur Anifah binti Muhammad Nizam. Today I want to present about grouping assignment. In this assignment, I will present about beam. So, FCU equal to 30 N per mm square and FY equal to 460 N per mm square. For B, 3000 mm. For H, 6000 mm. Diameter of bar 25 and cover for beam 40. Calculation load for dead load 20 kN times 2 equal 40 kN. Live load 5 kN times 2 equal to 10 kN. For safe weight beam, 0.6 times 2 0.3 times 2 24 equal 4.32 kN per m. For ultimate load, 1.4 GK plus 1.6 QK. So 1.4 times 2 40 plus 4.32 plus 1.6 times 2 10 equal 78.04 kN per m. For design moment, M equal to WL square over 8. So 78.04 times to 5 square over 8. So the answer is 243.87 kN per m. For effective depth, 1600 minus 25 over 2 minus 40. So the answer for depth is 547.5 mm. Next, K equal M per FCUBD square. So 243.87 kN per m times to 10 over 6. Divide to 30 times to 3000 times to 547.5 square. So the answer for K is 0.090. So so it's below 0.156. Next, compression reinforcement. For compression reinforcement Z equal to D in bracket 0.5 plus square root 0.25 minus K over 0.9. So 547.5 in bracket 0.5 plus square root 0.25 minus 0.090 over 0.9. So the answer is 485.79 mm. So it's below 524.88 mm. For AS equal to M over 0.95 FYZ. So 243.87 times to 10 over 6 divide to 0.090 divide to 416 divide to 485.79. So the answer is 1148.75 mm. From table 1, provide use 3T25 equal to 1470 mm square. For shears, ultimate design load is 78.04. For ultimate design shear force, which is V, is 78.04 times to 5/2. So 195.1. Next, V equal to V per BVD. So 195.1 times to 10 cube over 300 times to 547.5. So the answer is 1.18 N per mm square. So for V, it's below 0.8 square root FCU. So 1.18 N per mm square is below 4.38 N per mm square. For area of steel, 1470 mm square. So 100 AS over BVD. So 100 times to 1470 mm square divide to 300 mm times to 547.5. So 0.89. So for V, 0.57 plus 0.63 minus 0.57 times to 0.89 minus 0.75 over 0.25. So the answer is 0.60 N per mm square. Since FCU up 25 N per mm square, VC can be multiplied by square cube root FCU over 25. So VC is equal to 0.60 N per mm square times to cube root 30 over 25. So the answer is 0.63 N per mm square. So VC plus 0.4 equal to 0.63 N per mm square plus 0.4. So for VC, 1.03 N per mm square. So the last part is deflection check from BS 8110 table 3.10. Basic span or depth limit for simply supported beam is 20 m. So L over D equal to 5000 divide to 547.5. So the answer is 9.13. So it below 20. So it's okay. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Marina binti Muhammad Bara and I will present about the column design for our grouping assignment. So FCU that we use in this column design is 30 Newton per millimeter square. After that is FCY that we use in this column design is 460 Newton per millimeter square. And then the percentage of main steel is provided is 2.5%. After that is we search for dead load from beam to slab. Dead load from beam to slab that we get is 44.32 kilonewton per meter square. After we get the answer, we times it with 10 meter square because the 10 meter square is the area supported by column. So the answer that we get is 443.2 kilonewton. So 443.2 kilonewton is the axial load for column. So by using the equation Newton equal to 0.4 times with FCU times with area of concrete plus with 0.8 times with area of steel times with FCY, we can get the area of column. So area of column that we get is 21,205.74. So by the area of column that we get, we can search the size of column. Size of column that we get is 145.7 0.62, and then we take the 200 mm size of column. So size of column that we use is 200 mm divided by 200 mm. So after that is we go to the numbers of reinforcement bar. Numbers of reinforcement bar that we use is, we must take it from table of group bar 3.10, and then we use for high tensile reinforcement with 20 size of bar. After that we search for minimum length. For minimum length, we can get it from 0.25 divided by 20, and then we get 5. But we take it 6 millimeter. After that is spacing length. Spacing length is 12 divided by 20, and then we get the 240 millimeter square. So the spacing length is 240 millimeter square. Lepas tu maximum height of column is, we get is 3000 millimeter square or 3 meter. That's all.
Good morning and Assalamualaikum everyone. My name is Evan Dinil Miki, and I'm gonna talk about the pad footing for our project. First of all, I'm gonna talk about the size of base, which is contain service load. Service load that we got is 371 kN, and from that we provide a 1.36 square base. And then moving to the next step is base reinforcement. The total axial load is 534.4, and the ultimate pressure is 288.93. And moving to the next point is assume an overall depth. We assume the depth is 45. Moving to the next one is bending. The bending, the K value is 0.810, that bigger than 0.156, and we use the 0.156 to calculate Z, and Z equal to 0.87. And moving to the next one is to calculate the AS. We got AS for 3160.98, and from that we provide a T32 bar at 250 mm center. For the AS is 3220. The distribution of reinforcement in determined. So after the calculation, we got 251.25. That's LC is bigger than this one. And moving to the next one is the vertical shear. For the vertical shear, we got 3.44, and the critical shear stress, which is the VC, we got 5.26. So when VC over V, the maximum shear at column is satisfactory and no shear reinforcement is required. And moving to the last point is punching stress. The shear stress VC equal to 8.006, and the critical perimeter 1340, and the area within the critical perimeter is 210.92. And that's all for me. Thank you.